Hello everyone, I'm João from That's Brilliant. In this video, we're going to talk about the derivative of e to the x. So, we're going to have some videos, more than one, proving mathematically the derivative of this function. So in this video, we're going to have the first of those mathematical proofs. And just to remember, what is this e? This e here is a mathematical constant. It has a value, a numeric value, and it is approximately equal to 2.7. And we can define this using a limit. I'm not going to talk in this video about the e number. We're going to talk about the derivative of this function. But just to remember, we can define this number as being the limit as, for example, n approaches infinity of 1 plus 1 over m, all of this raised to n. And this limit is equal to e. And we want to take the derivative of this function. So let's say you have f of x equal to e to the x. And we want f prime of x, the derivative of this function. And we know that the derivative of this function is e to the x. So if you have e to the x and you take the derivative with respect to x, you obtain e to the x. If you have e to the x and integrate this function, we have again e to the x. So the derivative of e to the x is e to the x. It doesn't change. Take the derivative, you can continue, it's always going to be e to the x. And we're going to prove that this is true. So we're going to do this mathematical proof in a unusual way. Let's see. We're going to start with the natural log of e to the x. And we know that natural log is the logarithm base e, and the argument is e to the x. So we know that this is equal to x, because this logarithm is asking to which exponent we're going to raise e in order to obtain e to the x, and the answer is x. Another way of saying is, if you have an exponent in the argument, you can put this exponent multiplying, and we have x times this, and logarithm base e of e is 1. So 1 times x is x. The second way is using a property of logarithms. But you can see easily that this is equal to x. So we're going to take the derivative of this function. And we're going to use this to prove the derivative of e to the x. So we want to know the derivative with respect to x of natural log of e to the x. And as we saw here, this is equal to x. So this is the same thing as writing gx of x, the derivative of x. And you know that this is equal to 1. Now let's take the derivative of this function in another way, using the chain rule. So we have the derivative, let me write it again, with respect to x of natural log of e to the x. And imagine here e to the x as being a function, let's call it u. So you can imagine this as a composition of two functions, because you have natural log of u, and u is a function with respect to x. So you have the natural log of a function, and this function is a function using x. So you can see here that you have a composition of two functions. So you can use the chain rule. And in simple words, the chain rule says that the derivative of the function is the derivative of the inside function times the derivative of the outside function. So writing this here using the chain rule, we see that this is equal to the derivative of natural log of u, the derivative in respect to u of natural log of u, times gu gx times the derivative of u with respect to x. So we're going to take the derivative of natural log of u as being just natural log of something, and then we're going to multiply by the derivative of u with respect to x. So, continuing here, let's remember, if we have a function, for example, natural log of x, and we take the derivative with respect to x, this is equal to 1 over x. This derivative is very famous, and I'm going to use it here. So, if the derivative with respect to x of natural log of x is 1 over x, the derivative with respect to u of natural log of u is 1 over u, or u raised to the negative 1 power. And I'm going to multiply that by the derivative of u with respect to x. But u is e to the x. So this here is the derivative with respect to x of e to the x. So times the derivative with respect to x of e to the x. So now let's get back to the beginning. We started with this function. We saw that the derivative of this function is equal to 1. But we also discovered that the derivative of this function is equal to this here. But if the derivative is equal to 1, the derivative is equal to this must be equal to this. We made no mistake. If this is equal to this, and the same thing is equal to this, these two things must be equal. So, 1 over u, and now I'm going to write u as e to the x. It's the same thing. We define a u as being e to the x. So 1 over e to the x times the derivative with respect to x of e to the x is equal to 1. And this is what I want to know, the derivative with respect to x of e to the x. So if we multiply both sides by e to the x, we discover that the derivative with respect to x of e to the x is equal to e to the x. And now we have proved the derivative of the function e to the x as we wanted. So we made no mistakes here. This is a different way of proving that the derivative of e to the x is equal to e to the x. So this is it. Thank you very much for watching, and I see you in the next videos.